Alright, we're going to talk about the domain and range basically of log functions and exponentials here. So here's a log function. It's a log base 2 of x. Notice the graph goes to the right forever, but basically this starts here and it goes down towards that way forever, but never quite gets x equal to 0. X equal to 0 is not on this graph. Okay? And let's just see why. So this is y equals log base 2 of x. If x is 0, then I have this question, which turns into what question? 2 to the y equals 0. Can you raise 2 to some power to get 0? Well, 2 to the first is 2. 2 to the 0 is 1. 2 to the minus 1? No, that's a half, right? So all of a sudden we're getting closer to 0, but we're never equaling, right? What's that? That's a fourth. That's an eighth. Okay. So you see, no matter what I put in here for the x values into here, I'm never going to quite make 0. So the domain of just a plain log function like this is greater than 0. So domain of just a log function with nothing affecting the x is greater than 0. Let's look at this with its inverse. So you can see this, that y. So here's my log function right there. Here is the inverse of that, right, which is base 2, which is this guy, the exponential. Let's look at the exponential first, okay? Look at the domain of the exponential. It starts way far left, and it goes here and goes way far right. It spans the whole thing. So the domain of the exponential is all real numbers, right? You can put anything you want. You can raise 2 to any power, negative or positive. Well, what's the range of an exponential, though? What's the lowest value? Do you ever get to 0? Well, we just got to saying 2 to some power never equals 0, right? So you never get to 0. So it's from 0, and then it goes up, right? The range is all values for y that are greater than 0, because look, it goes forever. Now remember, its inverse is the log function, right? That's what I'm telling you here. So their domain and range are swapped. The domain of the log must be the range here, right? So look, they get swapped here. This x value of 1, 2, this x value of the 1 is now the y value. So it's swapped 2, 1. So the domain must be what the range was of the exponential. Again, greater than 0. So this time we say x is greater than 0. What's the range? Well, it should be all real numbers. Let's check it. Does it produce all real numbers for the y values? Yeah, it goes from the lowest number here, and it keeps going up. Even though a little slightly, it still goes up like this. So it produces all the y values. So the domain, again, of a log function is greater than 0. The range is all real numbers. The exponential one, on the other hand, that looks like this, the domain is all real numbers, and the range is greater than 0. So let's look at a couple examples here, or an example, and then have you try one. If it said find the domain of the log base 10 of x minus 5, this function here, well, remember, this inside area right there must always be positive. Okay, must stay positive. So x minus 5 must be greater than 0. Can't be equal to 0, must be just strictly greater than. Add 5 to both sides, and there we go. X is greater than 5. Easy as that. And if you think about it, it's a log graph, base 10. It looks very similar to the other one. Base 10, log base 10 of x. Just looks like this, going through the same point, just has a couple other different ones here. But then it's been moved to the right 5 units. So I move every point to the right 5 units. And that's what this does right here. Every x value greater than 5 will work in there, right? So you can see that. Now let's have you try these two down here. So pause it and tell me what the domain of this log function is and what do you think the domain of this exponential function is. Alright, so this log function, it says 3 times the log base 25 of x plus 9. Well, if I'm looking at this, base 25 is just the base. 3 says 3 times all this output here. What's the input? X plus 9. So it's just been moved to the left 9 units, right? And we need to keep this greater than 0, so subtract 9 on both sides. That's the domain. If I choose numbers greater than negative 9, I can do that. Watch, negative 8 works. Negative 8 plus 9 is 1. And I know the log of base 25 of a 1, right? 25, that's 0. So then 3 times 0 is 0. Okay? So basically, I mean, you make this positive and you're set. Greater than 0, positive. Okay? Over here now, the exponential, can I put any number I want up here? Well, this exponential has been shifted to the right too, but that doesn't affect the domain, right? Because I can subtract 2 from any number. I can subtract 2 from 10, 5, negative 2, 0, whatever. So still all real numbers.